Okay, welcome back to the last installment of the lesson for section 11.6. In this section, we're going to take a look at about maybe 4 problems where we investigate the equations or quadratic functions that are written in the form of a times x minus h, the quantity squared, plus k, and see how we work with these and graphing these, how we manipulate these, and so on and so forth. So let's go ahead and we're going to jump into 46. So in this, I should clarify before we start here what we're going to be asked to do with these questions going forward for this video. So the first thing we're going to be asked to do is we're going to be asked to graph the function. You're going to be asked to find the maximum and minimum value. You're also going to be asked to find the range. Now, the one thing so that's at least a few of these questions here. I will, in the course of these questions, be also asking you to find the vertex as well as the axis of symmetry. Take good notes on this because in section 11.7, you're going to be asked to do this work on several problems. And whereas I will do all the work for some of the questions in 11.7, I'm not going to focus on reteaching this again in 11.7. We're going to have to do additional work to write quadratic functions in the form of f of x equals a times x minus h squared plus k. They won't be written in this way. Our job in that section is going to be to write them in this way. So that's going to be the focus in section 11.7, because once you are able to do this, and once you get them in that form, everything else you need to do in 11.7 is going to be essentially the same as what you've learned in section 11.6. So I will take a question, maybe every third question, and work it out from beginning to end. But the focus of section 11.7 is, of the lesson anyway, is going to be to write the equation into this form from another form. So let's go ahead and continue into the next lesson here. Let's take a look at question 46. So the function in question 46 is going to be f of x equal x plus 3 squared minus 2. So finally we have a value of k in this one. No value of a, but we have a value of k. A is going to be 0. H is going to be careful, is going to be negative 3. This is supposed to be a negative here. That means that this 3 came in as a negative. K is going to equal negative 2. So the first thing we should be able to identify quickly from this is we should be able to identify the vertex. And the vertex is going to be negative 3, negative 2. So we'll go ahead and put that point down on our graph now. And we're going to put that right there. Another thing that I'm going to change a little bit in this lesson is going directly to at least identifying the equation of the axis of symmetry. So for the axis of symmetry, I'm going to go ahead and define the equation for the axis of symmetry as being equal to x equals negative 3. Where do I get that from? I get that from the x value of the vertex. So I can write the equation of the axis of symmetry as x equals negative 3. So we have the vertex, we have the axis of symmetry, we now need to graph this. So you're going to see as I'm going to use more space here because of the more work that we're going to have to do here. So, and I'll be using some of the other space here too. So this is going to be x. This is going to be x plus 3 squared minus 2, and here's going to be y. So in this problem, I want 5 spaces again because I need 5 points to plot. I'm going to put the vertex in the middle, at least the x value, so that's going to be negative 3 here. So from negative 3, I'll count negative 4, negative 5, and here I'll count negative 2 and negative 1. I'm going to go ahead and obtain these points now. So this is going to be negative 5 plus 3 squared. This is copying down as I copy them down. Again, save yourself some space. If you cannot do this in your head, you may want to save a few lines underneath here. Negative 5 plus 3, that's going to be negative 2 squared. Negative 2 squared is 4. That'll be 4 minus 2 is 2. This is going to be negative 1. Negative 1 squared is 1. 1 minus 2 is negative 1. This, of course, now be careful. What's the vertex now? Negative 3 plus 3, that's 0. 0 squared is 0. That's going to be minus 2. And you should expect that this will be negative 1 and that this will be 2 because of the symmetry we discussed earlier. Negative 2 plus 3, that's going to be 1. 1 squared is 1, minus 2 is negative 1. Negative 1 plus 3, that's going to be 2. 2 squared is 4. 4 minus 2 is 2. So now we have our values that we can put onto the graph. And we're going to go ahead and do that. Oh, by the way, guys, I made a mistake here. A is not equal to 0. My apologies. A is equal to 1. It's not there, but we just assumed that it's a 1. So A is equal to 1. Let's go ahead and plot these points down. So we have the points here, negative 4, negative 1, negative 5, 2, negative 2, negative 1, negative 1, 2. And we're going to go ahead and put our graph down. We're going to go ahead and put the axis of symmetry down. There are two more things we're asked to do in this question that we weren't asked to do before. We do have the vertex, we have the equation of the axis of symmetry, we have a graph of the axis of symmetry, and we have the points that establish the graph of the problem. The two other things we're asked to do is establish if this is a maximum and a minimum and what that is. Well, the nice thing is we can look at the graph, and if we have to choose between a maximum and minimum, we can see that this is bottoming out, so this is a minimum. And just like we get the axis of symmetry from the x-coordinate of the vertex, we can get the minimum value from the y-coordinate of the vertex. And that makes sense. The y-coordinate of the vertex is negative 2. So just like we can get the axis of symmetry here, we can get the minimum value from the y-coordinate of the vertex. So for the axis of symmetry, we look for the x-coordinate of the vertex. But for the maximum or the minimum value, we can look to the y-coordinate of the vertex. And that minimum is going to be negative 2. The last type of question that you're going to be asked about is what the range is going to be. And here's where you have to decide. Is it going to be negative infinity to negative 2, or is it going to be negative 2 to infinity? Well, since this is a minimum, negative 2 is the lowest that this can go. And as far as where it's going to go up, sky's the limit. So we write this as infinity, and then we call it a day. So we've answered all the components of this question. So we have our vertex, we have our axis of symmetry, we have the graph, we have established that it's a minimum at x equal at negative 2, not x equals negative 2, that's axis of symmetry. And then we have a range of negative 2 to infinity. Let's compare that with another problem we're going to do on this side. I'm just going to flip this worksheet over here so we have more space to show our work. Let's take a look at another problem that has a negative value of a now. So we're just going to take a look at 48. It's going to be f of x is going to equal negative the quantity of x minus 1 squared plus 3. So here again, we're going to establish our value of a, h, and k. A is negative 1 now because of the negative in front. H is equal to 1. K is equal to 3. So now that we have that, the first thing we're going to do is I'm just going to put this work under here. Let's establish the vertex. The The vertex is going to be HK, so the vertex is going to be 1 and 3. So we can go ahead and put that point down, 1 and 3. And there it is. We know the axis of symmetry we're going to get from the x value. And the axis of symmetry is going to be x equals, we get that from here, x is equal to 1. Another thing you may want to do here too, because we know from the previous problem we can obtain the maximum or minimum from the y-coordinate of the vertex, is we know it's going to be a 3. But you may not think to know if this is the maximum or minimum. Now, based on the fact that the value of a is going to be minus, my bet is that this value of 3 is going to be a maximum. But if you don't feel comfortable with that conclusion, we can just put the graph down first and then draw that conclusion from there. So, let's go forward. I'm going to go ahead now that I have my vertex and axis symmetry. Let's generate a graph. So this is going to be negative x minus 1 squared plus 3. And I have a vertex of 1, 3, so when I put my values in, I put the 1 in the center, 0, negative 1, 2, and 3. I'm going to put these in now. Again, you may want to save yourself some room. And we'll go ahead and do the calculations. So I'm going to just generate these down because I believe you can do these yourself. So 2 squared is 4. Now it's going to be, when I did this 4, it's going to be negative 4. Negative 4 plus 3 is going to be, is that right? So negative 1 minus 1 is negative 2. Negative 2 squared is 4. Negative 4 plus 3 is going to be negative 1. Okay, why don't I like that number? Oh, yeah, because that's further down. 0 minus 1 is negative 1. Negative 1 squared is 1. So let me show this. 0 minus 1 is negative 1. Negative 1 squared is 1. Minus 1. Minus 1 plus 3 plus 2. 1 minus 1 is 0. All this is 0. 0 plus 3 is 3. 2 minus 1 is 1. 1 squared is 1. Negative 1. Negative 1 plus 3. 2. 3 minus 1 is 2. 2 squared is 4. Negative 4 plus 3. Negative 1. So now I have my 5 points which I can plot down. So negative 1. Negative 1. 0, 2. My apologies for my phone going crazy in the background. 2, 2. And 3, negative 1. So here are my 5 points for the graph of the parabola. We now have this graph. It doesn't have to be perfect, but it should have arrows. It should connect all the points. It should be fairly free-flowing. So we have the vertical vertex axis of symmetry. As we mentioned, we can use the y value to determine the maximum or minimum. In this case, it looks like indeed that vertex is going to be a maximum. And if you want to determine the range, since 3 is the maximum, if we're looking at the range for this, then it looks like the maximum is 3. That's as high it goes as it goes. It's going to be coming from negative infinity, going down to negative infinity. So the range for this would be negative infinity, all the way up to and including 3. Let's go ahead and take a look at one more problem to kind of help you along and see how you do. So for this one, we're going to take a look at one that involves some fractions now, but the fractions at this level don't seem too bad. So this is going to be question number 62 now. And this is going to be f of x is equal to 2 times x minus 5 squared minus 3. Let's go ahead and establish the values of a, h, and k. A is equal to 2, h is equal to 5, k is equal to negative 3. So we're going to have a vertex then, let's establish that here, of 5, negative 3. So 5, negative 3 is going to be right here. So we know that A is equal to positive 2. So we anticipate this is going to be a smiley face, so this is going to be a minimum. But first, axis of symmetry. The axis of symmetry should be, well, we get it from here. X equals 5. Next thing I'm going to do is, let's go ahead and I'm going to, no, I'll save this here just in case. Next thing I'm going to do is, I know that I can get either a maximum or minimum, and because this is positive, when we graph this, and we're going to graph this, we should establish that this is a minimum because the graph is going to go upward because this is positive. So we're going to say it has a minimum at the y value of the vertex where it has a minimum at -3. And if it has a minimum at 3, we can say that the range of this is going to be from -3 all the way to infinity. Okay, so going forward on this, we're going to go ahead and we got 4 to 5 bits of information here. We're going to go ahead and generate a graph of this now too. So I'm going to do this over here. So notice we have quite a bit to calculate now. So we've got 2 times x minus 5 squared minus 3. This will give us our y values. I'm looking for 5 of them. Since the x value for the vertex is 5, I'm going to put 5 here, 4, 3, and 6, and 7. So I'm going to pick those values. Again, you may want to save yourself some space below to do your calculations. So those are going to be 2 times 3 minus 5 squared minus 3, 2 times 4 minus 5 squared minus 3, 2 times 5 minus 5 squared minus 3, 2 times 6 minus 5 squared minus 3, 2 times 7 minus 5 squared minus 3. And let's put these together. 3 minus 5 is -2. -2 squared is 4. 4 times 2 is 8. 8 minus 3 is going to be 5. 4 minus 5 is -1. -1 squared is 1. 1 times 2 is 2. 2 minus 3 is -1. That's going to be 0. 0 times 2 is 0. Minus 3. This should be -1, but let's see. 6 minus 5 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 3 is -1. 7 minus 5 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. And there are going to be our points that we're going to put down here. So let's do that. 3, 5. 3. So we're going to start from here. 3, 5. 4, -1. We already have the vertex. 6, -1. And then 7, 5. So one of the things I want to draw your attention to the graph of this parabola, you'll notice that compared to a parabola where there's an a coefficient of 1, or where the a was equal to 1/2, that this parabola is significantly, not significantly, but it's more narrow. And the smaller the value of a is, like when a is less than 1, it's going to make that graph narrow again. So we have the vertex, we have the axis of symmetry, we have that it's a minimum, we have the range, we now have the points to make up the graph of the parabola. We've now solved this problem. So I think this is enough to kind of go forward with. If you have any questions, you may please feel free to go ahead and ask those questions in class about this. I will see you in class to be of further assistance later. Also, there's one other thing I do need to show you actually. So what I want to do is there are a few questions at the end where it says without graphing. It's going to ask you to find the vertex, the axis of symmetry, and the maximum value or minimum value. So let's just go ahead and take a look at one of those questions very quickly here. So let's just take a look at a question like 66. The function you're going to be given is f of x is going to be given 4 times x plus 5 squared minus 6. So everything kind of derives itself from the vertex. So you're asked to find the vertex, axis of symmetry, or maximum and minimum value. So the first thing we can do is identify the vertex. The vertex is going to be -5 and -6. The axis of symmetry we get from this, so the axis is going to be x equals -5. Now, here, this is what you have to know for whether it's a maximum or minimum. As long as a is greater than 0, it's going to be a minimum. If a is less than 0, it's going to be a maximum. So if a is greater than 0, like it's positive, it's going to be a minimum. If a is less than 0, that means it's negative. This is going to be a max. Since a is greater than 0, it's going to be a minimum. So it's going to be a minimum. Where is it going to be a minimum? At the y value of the vertex, -6. If you want to go so far even to find the range, since you know this is the minimum for the range, even though they don't ask for it, you could simply write the range as -6 all the way to positive infinity. That wraps up our lesson for section 11.6. You will need all of these same skills to do the work in 11.7, and I will help you do the questions in 11.7, but I will only work a few of them out completely. What I will focus on the main thing, which is to get the equations written into this type of form so that you may do the rest of this work on them. See you in the next lesson.